Hello everyone, welcome to Flexible Authorization with ASP.NET Core. I'm Jason Taylor, Solution Architect for Increment. As you can see, I'm a developer, mentor, speaker, and trainer, and most recently awarded Microsoft MVP in Developer Technologies. I've been working with .NET since 1.0 in 2002, and before that I was doing VB Script and Classic ASP. Today we're here to talk about flexible authorization with ASP.NET Core. And before we can dive into that very interesting topic, we have to cover a little bit of background. So let's start with the basics. Authentication is the process which determines a user's identity, whereas authorization is the process that determines which resources a user can access. While authentication is independent of authorization, it's important to remember that authorization requires an authenticated user. So authorization determines access to resources. But what exactly is a resource? Well, it can include many things, such as access to a feature in a system, files on a file system, or data in a database. Authorization also includes defining and enforcing access control rules as policies, which are then used by the system to grant or reject access requests to specified resources. The focus of this talk will be authorization with ASP.NET Core. I'll demonstrate a basic approach using role-based access control. And you'll see that for a sufficiently complex system, that approach will slow developer productivity and decrease overall maintainability. Then, by extending the ASP.NET Core authorization framework, I will demonstrate a flexible approach to overcome those limitations. Now in this talk, I'll provide some live demonstrations using an app that was built with Blazor WebAssembly and hosted on ASP.NET Core. And I'll share a link to the code and slides at the end of this talk. So with ASP.NET Core authorization, it supports simple authorization capabilities, such as allowing access to an authenticated user. But it also includes some very sophisticated checks, such as role-based, claims-based, policy-based, view-based, and resource-based authorization. It's easy to create custom authorization policies to verify very specific requirements, and it's also easy to customize the authorization middleware to suit your needs. So we have a very powerful framework supplying both simple and sophisticated capabilities with the ability to extend it. Let's start with some examples. In its simplest sense, ASP.NET authorization uses the authorize attribute. You can apply that to a controller, action, or razor page. In this example, the attribute's been applied to the account controller. And what this means is that only authenticated users will be able to log in or log out. So clearly that's a problem. If we move the authorize attribute down, anonymous users will be able to access the login action, and authenticated users will be able to access the logout action. We also have the allow anonymous attribute. And so in this case, the accounts controller is locked down to authenticated users, except for the login action, which will allow anonymous users. ASP.NET Core supports role-based authorization. Again, using the authorize attribute, we can specify which roles are required to access. In this case, the user must be authenticated and be a member of the administrator's role in order to access the administrator controller actions. In this case, the user must be authenticated and a member of either the administrator's or the accounts role. It doesn't have to be both, one will be fine. And in this case, the user needs to be a member of both. So we've specified two authorized attributes, and so the user must be a member of administrators and accounts in order to gain access to the accounts controller. ASP.NET Core also supports policy-based authorization. You can see here we've used the authorize attribute and specified the employees only policy. This means that for a user to gain access to the employee's controller, they must be authenticated and satisfy the requirements of the employees only policy. This is the definition of the policy, where we've specified the name as employees only, and the only requirement it has is that the user has a single claim, the employee number claim. We're not concerned with the value of the claim or what their employee number, just that they have it. Authorization in Blazor WebAssembly is of course very similar, being that it's another ASP.NET Core technology. It supports the same basic authorization capabilities, such as allowing access to an authenticated user or allowing access to an anonymous user. It includes the same sophisticated authorization capabilities, such as role, claims, and policy-based. And it also includes a number of helpful authorization components, such as the authorized view and the authorized route view. And we'll take a look at some examples. Need to remember that with Blazor and other front-end technologies, Blazor WebAssembly in this case, authorization is only used for UI UX. So it's to provide a great user experience. But these checks can easily be bypassed, and so the authorization that happens on the server is very important. Let's look at some examples. We can apply the authorize attribute to a routable page. In this case, the home page will only be accessible to authenticated users. Next up, we're using the allow anonymous attribute. If we like, with Blazor WebAssembly, we can lock the whole site down to authorized users. If that's the case, this allow anonymous attribute will allow unauthenticated users access to the login page. We can support role-based authorization. In this case, the counter page is only accessible to members of the administrators or accounts role. We can support policy-based authorization. The users page is only accessible to users who meet the requirements of the employees only policy. And we have the authorized view component, which we can use to selectively display content. You can see for the home link, it'll be available to authenticated users. The counter link is restricted. You'll need to be a member of either the administrators or the accounts role. And finally, the users link is restricted. You'll need to satisfy the requirements of the employees only policy. Here we have an alternate use of the authorized view component. For not authorized users, this will show the login page. So in this case, that means anyone who's not authenticated. Let's dive into our first demo. In this demo, we're going to add a role to an existing application. Now, this will be the basic approach to authorization using role-based access control. And the scenario is that we have some auditors coming on board, and we need to create an auditor's role, which gives them the necessary permissions within the system. So I've built a simple application. As I mentioned, this is Blazor WebAssembly hosted on ASP.NET Core. And I'll go ahead and log in. I'll log in as the administrator, and we can have a look at these features. So we have the home page, the counter page. That's currently restricted to administrators or the accounts team because they like to count things. The fetch data one, that's restricted to the administrators or operations because they need to check the weather. We have users. Most roles can view this page, but only administrators can edit. Now, if we go edit on the auditor, you can see we're able to specify which roles this user will be a member of. Accounts, administrators, or operations, and of course we'll need to add an auditor's role because none of the existing roles will meet the authorization requirements. We also have claims, which is just there for development purposes. At the moment, we can see that there's an interesting roles claim, and it specifies what role I have as an administrator. So if I'd like to create a new role, I'll need to do that in code. I'm currently doing it in my basic auth.server project, and I have a DB initializer. So if I expand that out, you can see here I've defined some roles as constants. I'm going to duplicate this one and use multi-cursor, and we'll, oh, that's not multi-cursor, hang on. There we go. We'll create our auditor's role. You can see that the users come with a default password. I watched a talk on hacking on Wednesday, and they said this password was very popular at the moment, so I chose that one. So everyone, it's the secure version, of course, right? Because it's got the exclamation mark. All right. So now we need to add the role. So I'll duplicate this. Use multi-cursor again. I love that feature. Auditors. And that's about all we need to do. So we've created the auditor's role. We need it to kind of end up in the database, so I'll go ahead and restart the app. Give that a moment. And then, so the next thing we need to do is we need to log in as the administrator, or go back as the administrator, assign the role to the auditor, then we can log in the auditor and see if they have access yet. Let's see, users, auditor, auditors, save. All right, so the auditor's been assigned the auditor's role. I can log out, log back in. Change that to auditor. And of course it's the same password so that users don't have to remember too many passwords. All right, now unfortunately, the auditor still doesn't have access to anything, right? We've created the role, but we're using role-based access control. So now we have to go and put role-based access control checks throughout our code. We want them to have access to the counter, fetch data, and the list of users. So let's do that now. We'll start on the front end. We've got a lot of work to do. So inside of client, I'll go to pages and I'll start with counter. That's really easy. We have the authorize attribute here. So I'll go ahead and add auditors as one of the roles that will be able to access the page. Now we'd like to do fetch data. That's for the weather forecasts. We'll include auditors there too. And we need to do users. And so this is for the list of users. We'll give auditors the ability to see the users. Now, that'll give us access to the pages, but it doesn't open up the nav menu. So let's go and adjust that too. So that's inside of shared nav menu. Here, we have our home link, our counter link. All right, so we open that one up to auditors, fetch data, same, and user list, same. Okay. So that should open up the front end nicely. Let's see if it's changed. Yeah, okay, so we've got counter. We can click on that. We can go to fetch data. We can access it okay, but we can't get the back end data because the API is still locked down. We haven't done the access control checks on the back end, and user is the same. So let's move it over to the server now. So we'll start with the forecast controller. So the weather forecast controller is currently open to administrators and operations. So we'll extend that one and we'll give them access to the users controller. And we'll give them access to the roles controller because they'll need to be able to see the list of roles. They're probably getting a little bit more access than what they need here. And that's one of the issues with role-based access control. It's not fine-grained, okay? So we have to do a little bit more work. But we won't do that today. So I've saved those changes. It should be ticking over okay. Let's see. Yeah, we can see the list of users. We can fetch some data. If we click edit, we get access denied because I didn't open up the edit page. So we should probably clean that up as well. But I think we've done enough work. So skipping back, so we added the new auditor's role to the existing application using basic authorization techniques, so role-based access control. You can see it was quite a lot of work. It wasn't simple to add at all, and we'll have to do that anytime we introduce a role. We'll also have to do that if authorization requirements change. So with that in mind, let's think about what would flexible authorization look like. What would that mean? Well, first, it would be easy to add new roles and to configure access control for those roles. It would be easy to reconfigure access control for existing roles. Requirements change, permissions change. We need to be able to do that quickly. It would be good if we could remove roles without impacting existing access control checks. Obviously, we have no hope of doing that now because we have to go and update the front end and the back end and build, test, deploy, publish, right? There's so much to do. It'd be great if we can easily view the access control policies. Now I've got us covered there. I've got a wiki, a little bit of a markdown document that we can maintain. Unfortunately, it's already out of date, but as a developer, I love documentation, so I'm going to get right back on that. It'd be really great if we could support all of the above as standard application features. Okay, I don't want to have to maintain documentation. I don't want to have to code test and deploy. These are simple things. So now let's do another demonstration. let's do a demonstration where we demonstrate what it would look like adding a new role with the flexible authorization approach. I'll close some of this down so it doesn't get in our way. And we'll head over here. So this is the same application which has been upgraded with flexible authorization capabilities. So I've extended ASP.NET Core authorization to support permissions-based access control. So we want to add the new auditor role. I'm logged in as an administrator. I'm going to shoot over to roles. That's a new feature. You can see that I can edit and delete roles, and I'll add in auditors. I'll jump over to access control. We don't need to maintain a wiki document anymore. We can see access control at any point, and we can configure it. Now we'd like auditors to have access to view the users, to count things, and to check the weather. You can see administrators automatically get access to everything, including new permissions that we define. Those changes are saved automatically, so I can go ahead and log out and log back in as an auditor. All right, so that's not working exactly as I'd hoped. What have I done wrong? I didn't assign the role to the auditor. All right, let's get back out. I'm glad the passwords are all the same. Admin, that's who we want to be. That's great. Users, auditor, auditor's role. There we go. Logging out, back in. Auditor. There we go. So they've got access to the counter. They've got access to fetch data. They can see the users. We got rid of the edit link. We've got that little fine-grained access control now. So that's a much better experience. So you've seen the basic approach. You've seen the flexible approach. Let's compare a little bit. So the basic approach required us to write code changes, required us to test. We didn't do that, but we'll get to that. Build and deploy, probably fix some bugs. You know, that it's hard to get role-based access control right, especially if there are a lot of features, and documentation, which we'll definitely get to. Flexible approach, well, as developers, we weren't really required. What I just did could have been completed by an administrator or an authorized end user, so we were left with free time. So that means that we could have been working on a new feature or a bug fix, something a little bit more exciting, delivering business value in other ways. So one more demonstration using flexible authorization. Let's add a new permission. I'd like the orders to have the capability to view that access control grid, but not to configure it. So we'll have to create a new permission for that. With this implementation, I'm storing the permission in an enumeration, and it's called permissions. So this is a bit flags enum. And we'll go into that a little bit. View access control will be the next permission that I create. All right. Now that that's in place, I need to do some authorization checks. This time, instead of role-based authorization checks, we'll be doing permissions-based authorization checks. So let's do the front end first again. I want them to have access to access control, so we'll start with the nav menu. You can see here that we're using a flexible authorized view component. Now this is a component that I created to extend the out-of-the-box authorized view component. Along with allowing me to specify roles or policies, I can also now specify permissions. So you can see if you want to access counter, you need the counter permission. If you want to access fetch data, you need the forecast permission. Let's have a find access control. So currently it's locked down to just those that can configure access control. We'll change it over to configure or view. So that should open up the nav menu. Now we need to change the page. So if we go to the access control page, which is in admin, and open this up, you can see the whole page is locked down to configure. So we'll open it up to view as well. And scrolling down, we have a little checkbox here. And this checkbox is going to enable users to toggle that permission. Now, we only want to allow users with configure access control to actually be able to change access control. So we'll go ahead. I've got some code here, which is going to use the flexible authorized view component instead of this just having a checkbox. So the flexible authorized view component has specified an access control check. It requires configure access control. Now, if you're authorized, it will show a checkbox which will enable editing. If you're not authorized, that checkbox will be disabled and will not allow editing. So that's fairly straightforward. Let me think. So now we need to go to the server and apply some permissions-based access control there. So if I head on over to flexible auth server, controllers, and admin access control, the whole control is locked down to configure access control. So we'll take that. We've got two actions, one to get the configuration and one to update. So configure access control is required to update, and view access control, actually both, is required to get the configuration. So it's a either or. I think that should do it. Let's find out. I'll go ahead and restart just to be sure. Looks like we'll log in as admin. It'll probably refresh that actually. Give it a sec. I'll go for it. Logging in. Oh, I don't want to log in as admin. Oh, actually I do. That's lucky. It's going to do it. It's going to fail. Just waiting. Let me try again. Oh, there we go. Okay, so we're logged in as admin. We can go to access control. We can see our new view access control permission, automatically assigned to administrators. We'll assign it to auditors as well. That's saved. We'll log out, log back in, and change this over to auditor. We can see access control. We can click on it, and we can see how it's configured. So now the auditors have access to that. So that took a little bit of work, right? But that's normal. We built in a new feature. We implemented a new authorization requirement. So we expect to do some work when the authorization requirements change. So now let's talk about this flexible authorization engine, the internal workings of it, and then we'll dive in and have a look at the code and see how it all fits together. So with this flexible authorization approach, we need to create the necessary roles and permissions. We're using role-based and permissions-based access control together. We need to assign permissions to roles as required, as defined by business requirements. And we also need to add an additional claim to the authenticated user. So we'll add the permissions claim. So now we'll have the role claim and the permissions claim. We'll have permissions-based access control as required. We've done that using the authorized attribute, using the authorized view, and there's also a service in there, the authorization service, which can do permissions-based access control checks. And we will make this work by using dynamic authorization policies. So this is policy-based authorization. So we're combining three things to make this work. Role-based, permission-based, which is new, we're adding that in, and policy-based. So we'll need to manage our roles. We probably all understand that roles define a logical grouping of users. Sometimes it might represent an organizational department, such as accounts or operations. Administrators, or any authorized user really, can create a role as required. Administrators will assign permissions to roles, and we now need to start avoiding role-based authorization checks. Okay, if we're using the flexible approach, then any checks in code should be permissions-based. They will only change if the feature changes, if we have a new feature to introduce or the authorization requirements around that feature change. Role-based tend to change because of organizational changes, restructures, that sort of thing. Permissions, we'll use those. We need to manage those. They define granular access to resources. Developers create permissions as necessary, but permissions are not assigned directly to a user, okay? Permissions are assigned to a role, and the user will inherit the permissions of all assigned roles. So they can be assigned multiple roles and they will get all of those permissions. The authorization engine, as mentioned, it's built entirely using policy-based authorization. So these are out-of-the-box features that we're using. We've got a custom authorize attribute that we can specify the required permissions. That set of required permissions is actually translated into a policy name. And it's a special little name. It might say permissions 7 or permissions 101. And that number's important. That represents the permissions required. And that policy will then be dynamically created using a custom policy provider. And so essentially the policy will be created on the fly to enforce the permissions that we've specified are required. So now we can have a look at the code. We'll start by revisiting our permissions, but I've got a little interactive notebook that we can check out to understand that a little bit better. So as you saw before, the permissions are stored using C# enums, and I have a simpler example here. You can see that they're stored using powers of 2, and each little bit represents a flag. So you can see A is 1, whereas B is 1, 0. And we can combine these flags in really interesting ways. So we can specify the user permissions as permission A or C, and that essentially equals 1 plus 100 or 101. Do you see how we've brought those flags across, combined them together? So 5 distinctly represents A and C, and nothing else. The required permissions we've specified as A and B, or 11, those first 2 flags. Now we can output those permissions as a string. So user permissions, A, C, straight from the enumeration. Required permissions, A and B. We can output permissions as the integer value. So you can see user permissions 5, required permissions 3. So a single value to represent the permissions that the user has. We can check permissions. So looking at the user's permissions, they've got A and C. The required permissions, A or B. Are they authorized? Yes, because they have permission A. We can add permissions using the logical OR operator. So now the user has permissions A, B, and C. We can remove permissions using the logical exclusive OR operator. So now the user's back to A and C. And we can generate policy names based on the permissions. So the required permissions are A and B, which is equivalent to 3. So the policy name will be permissions 3. And so pretty soon I'll show you how ASP.NET Core will take that policy name and dynamically generate a policy to enforce those permissions. We can update required permissions in a policy name. You can see we've changed it A, B, and C. Here's another value, 7, and the policy name would be permission 7. We can also get the value of the permissions based on a policy name. So it's 7, we extract that value, we can convert that back to the permissions enumeration, and we've got A, B, and C again. So let's have a look at the code now. So we've seen the permissions enumeration. We'll load it up again. That's it. We also have a permissions provider, which is just a helper method to give me a friendly list of permissions so I can display it on the view. But the real magic starts within the flexible authorization policy provider. So this is extending the default authorization policy provider. With ASP.NET Core, you can only have one active policy provider, and so it'll be our flexible authorization one. Now the way that this works is we start in this method, get policy async, given a policy name. First thing we do, try to get the policy. We don't want to generate a brand new policy if it's not needed, so we'll just try to get it. If the policy doesn't exist, and that particular policy is one of our special ones, you know, it starts with permissions and ends with a number, whoops, then we'll go ahead and create a policy to match that. First thing we do is we extract the permissions from the policy name. Then we build a new authorization policy. We add one requirement that the user must have these permissions. We build it, and we add it, and we return it. And of course, if the policy already exists, we return it. And if it's not one of our policies that we want to generate, then what gets returned is null, which is the normal behavior for, I believe, for this default authorization policy provider. So this is building the policy. Let's dive in and have a look at the requirement, the permission authorization requirement. So you can see here, this is implementing authorization requirement from ASP.NET Core, but it's just a container for data. It just contains the required permissions. So what is actually going to do the check? It is the permission authorization handler. And this is where we retrieve the user, we retrieve the roles claim, we build the permissions claim. In this one actually, we just retrieve the permissions claim, and then we check against the user's permissions and the required permissions. So you can see here we retrieve the claim. If it doesn't exist, we bail. And that means that the user is not authorized as per this requirement. If the permissions claim value is not valid, we bail. Otherwise, we cast it into a permissions type. We check to see if they have the required permissions. And if they do, the requirement succeeds and we return. If they don't, then we bail again. Okay? Nice and simple. We're just extending ASP.NET Core. Let's have a look. What else have we got here? So this is the authorize attribute. We've been using that, but we haven't looked at the internal workings. So this particular one is just extending the ASP.NET Core authorization, authorize attribute. And you can see we're adding a new constructor so we can pass in the permissions. Nice to have. And we have this permissions property. What we're doing here, we're not storing the permissions. We're generating the policy name and storing that. So even at this level, with our custom authorize attribute, we're just using policy-based authorization. What else do we have? We've got our custom claim type, but that's just for the claim name. We've got the authorization service extensions, which is great. So when you're doing authorization checks with ASP.NET Core, sometimes it's nice to use the authorization service. If you have some procedural checks, some code, that way you want to do certain authorization checks, you can use this service. So I've gone ahead and built an extension on it, so you can go ahead and do permissions-based authorization checks. Should cover all of the bases. Let's see, we've looked at the handler, we've looked at the requirement, we've looked at permissions. We didn't look at the policy name helper. This one's very straightforward. It's responsible for generating a policy name, given a set of permissions. It's responsible for getting the permissions from a policy name, and also checking to see if it is a valid policy name. I think I need a better method name for that. I think I need to say, is this a permissions policy name, or is this a permissions policy? Something a little bit more descriptive, but that's the point of it. It's to check if it's one of our policies that we'd like to dynamically generate. All right. I think that is it. Okay. So today we looked at authorization with ASP.NET Core. I demonstrated a basic approach to authorization using role-based access control. Now this is a very typical approach. I'm sure a lot of us here have used it. With this approach, we saw that a simple requirement, such as adding an auditor role, took a lot of effort. We had to write code, we had to test that code, build, deploy, document, probably fix some bugs. We then looked at the flexible authorization approach. Now the flexible authorization approach was a dream if we needed to add a new role or a permission. We combined role-based authorization with permissions-based authorization, which we introduced, and we used policy-based authorization to dynamically generate policies to enforce those permissions. Now, if you have a simple application with a small user base, the flexible approach to authorization is probably overkill. You could get by with the basic approach. But for most large production applications, especially in big enterprises, the flexible approach to authorization is essential. With the flexible approach, you'll be able to isolate your code base from organizational changes. It'll free up developers to focus on delivering business value, such as fixing bugs or delivering new features, and it will put the power of access control into the hands of administrators and other authorized users. Thanks for attending my talk. I hope you've enjoyed it. If you'd like to learn more, you can check out the code and slides on GitHub. You'll find it at github.com/JasonTaylorDev/flexible-ASP.NET Core-authorization.